Okay, so in this video, we're going to look at the other examples that we had left from our notes today. The examples specifically have to do with taking derivatives of log functions where we have bases other than e. Okay, so if we're looking at example number 4, we have a log with a base of 8. And right now, we do not have a rule for us to be able to take a derivative here. Okay, so like everything else, we want to be able to look at this and ask ourselves, is there a way that we can rewrite this log with a base of 8 into something that we do know how to take the log for? Okay, well, we do have a rule for this, and if you recall back from Algebra 2 and pre-calculus, you had the rule of a change of base formula, where you're able to take any log and you can rewrite it using change of base formula into either a base with 10 or a natural log base. Okay, so our change of base formula says that if we have a log with a base of a of some function, we can rewrite this using either log log base 10, or we can use natural log. So since our rules that we know for derivatives involve natural logs, we're going to use our change of base rule involving natural logs. So if we want to change this into natural logs, this is going to just be equal to the natural log of u divided by the natural log of a. Okay, so that's the change of base formula, going from log of any base into natural logs. Okay, so now if we're looking at this, the u in this is a function in terms of x. The a is just some number, right? So that means that this natural log of a is a constant and natural log of u is a function. Okay, so now if we want to try to develop this derivative rule, if we want to take the derivative, and let's just say we're going to let this equal y. So when we go to take the derivative of this, first of all, I can rewrite this, since this is natural log of a, since that's just a number, I'm going to rewrite this as 1 over natural log of a times natural log of u. Okay, so now we just have some constant times the natural log of u function. Okay, and we know how to take a derivative here. The natural log of a, that's a constant, so that's just going to hang out front. And the derivative for natural log of u is just u prime over u. Okay, that's a derivative that we do know. Okay, and then if we want to kind of combine these or rewrite these, we can write this as u prime divided by u times natural log of a. Okay, so this is going to be our derivative rule. So derivative with respect to x of any log with a base of a and function u. Okay, so you can add that to your list of rules in your notes. This will give you rule number 3 for the derivatives. Okay, so now taking this rule and applying it to our problem here in number 4, we have log of base 8 of this function u. Okay, so thinking a step ahead, I certainly do not want to use the quotient rule whenever I go to find u prime. Okay, so just like our problems with natural log with a base of e, we just used our log properties and we rewrote this before we took a derivative. So we're going to do that here too. So y is just equal to log base 8 of x squared minus 8. And then we're going to subtract log base 8 of x minus 7. Okay, now we have 2 logs base 8. We can apply this new rule. So y prime, for our first derivative, we're looking at just this first piece. So we come here to our pattern and we say, okay, we need u prime. So that's going to give us 2x. And then we're going to divide that by u times the natural log of a. Okay, so natural log of a is going to be just natural log of 8, and then u is x squared minus 8. So I'm going to write this as natural log of 8 times x squared minus 8. Okay, and then we'll come over here and do the second one. So we need u prime, so that's just going to give us 1. And on the bottom, we'll have natural log of 8 times our u. And you'll probably want to get this into just one fraction because next thing, of course, we'll be doing things like relative extrema and meeting critical numbers. So if I want this as one fraction, I see I have a natural log of 8 in both of these denominators, so the only thing I'll need to multiply by are these functions to get the common denominator. So I will have 2x times x minus 7 minus 1 times just x squared minus 8 all over my common denominator, natural log 8, x squared minus 8, x minus 7. And my writing is really sloppy today. Okay, and then after simplifying that out, for our final answer, after we simplify out, we end up with an x squared minus 14x plus 8 over our common denominator. Okay, so we've got number 5 in our notes, so I would like you to try number 5 and have that for me to check in your notes on Monday.